Hello and welcome to TidyX episode 28. This is part 4 of our Shiny series. If you haven't seen the other episodes, I highly suggest you go see them. They're really informative and we're trying to cover super basic, like here's how you start understanding Shiny programming, to this point where we're kind of going into some a little bit more advanced concepts. This episode we're going to be covering situations like using action buttons to trigger events. We're going to look at reactive values and a bunch of other really fun stuff. And we're also going to look at an interesting algorithm that Patrick told me about that we're going to be using to find how similar other players when during their basketball careers, using Vorp. All right, so my name is Ellis Hughes. I am a statistical programmer. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. I do data analysis in sport, and you can find me on Twitter at OSPPatrick. You can find both of us on Twitter at Tidy_Explained, and you can always get in touch with us with questions or ideas for future screencasts. We'd like that.
Yes.
At tidy.explained@gmail.com.
All right, yeah, definitely. If you see anything you want us to explain, or any Tidy Tuesday posts you want us to kind of go through, tag the Twitter post or the Twitter channel or Twitter account that we have at Tidy_Explained, and we'll take that under consideration. We love to hear from our fans and our viewers. All right, so I'm going to start sharing our screen where we are. There we go. All right, so we've got our studio session going, and we're going to take you through KNN. All right, so that's KNearest Neighbors. So we're first going to give a little bit of background, like read in the data, and then Patrick's going to explain what KNN is. All right. So the data is from Kaggle. This is the same data that we've been using for the last couple of weeks because we wanted to use this consistent data set that we can really explore and go through. The inspiration for this project is from the Carmelo app on 538. Highly suggest you check that out. It's really interesting and a great way to show visualization. It's really information dense, and I really like it. All right, so the packages that we load up first are Tidyverse, as always, for the data manipulation tools that exist within that, and then FNN, which has the function that we use for KNearest Neighbors. Next, for plotting purposes, we want to set our themes for our ggplots to make it just automatically look a lot nicer. So we use theme set. We use theme BW because we think that looks nice, and then we have some additional theming where we're setting the element or the text sizes of our text and titles. We're going to remove the panel border, and we're going to set the grid major lines to be gray, just as a default setting there to make it look a little bit prettier. Next, we load in our data set. This is the same data set we've been using for the last several weeks. It's season statistics from Kaggle. So we load that in. I need here, excuse me, there we go, just so that I don't have to write the full path out. Here looks at your project and then works from there. It makes it really easy to write file paths. Then we're going to do some processing of the data. What we're going to do is we're going to take the season statistics and filter to keep only players and statistics after or equal to the year 2000. We're going to remove the X column, which is just like the row names. We don't really care about that. That's just an artifact from reading in the data set using read.csv. We're going to group by the player in the year because sometimes a player might be listed multiple times. We want to make sure that we don't double count them, essentially. So we're going to summarize across Vorp. We're going to add their Vorps together and set that to be the player's Vorp for that year. We're going to calculate experience. So we had to make some assumptions with their data set. Patrick, do you want to explain what was going on with that?
Yeah, well, originally I would prefer to do this based off age, but as we talked about in last screencast, the birth years were kind of messed up a little bit. So it was tough to find good birth years for these guys. Experience was the next logical step. The only assumption we're making here is that because we filtered the data to be year 2000 or greater, it is entirely possible that in sequencing along the player, there could be a player that is playing in year 2000 that the summary of our data here that we've just created sees that player as year 1 of experience being the year 2000, when in fact it could be year 3, 4, or 5, or something totally different. So that is a small assumption that we did make with this. If we had a table that maybe had their, their start year or the first time they made an NBA appearance, a game appearance, or something like that, it would have been better. But that's what we're going with. It's okay. Conceptually, it still works.
Exactly. And then max years is the total number of years that we saw them play. This, once again, making assumptions about the data set so that we could create some cool stuff for you. So now we've got this really long data set that has the players, each year they played, what the Vorp was for that year, which is value over replacement player, the experience that we see, the number of times we see them, and the maximum number of years they played as we see it as well. So next we're gonna okay. So Patrick, what is KNN?
Yeah, so this is a similarity-based approach, which is not too dissimilar to k-means clustering, which we've done in previous screencasts, with the idea that this is a non-parametric approach, a non-parametric algorithm. It can be used for classification or regression. We're going to use it for classification here. And the KNearest neighbor part means that we want to find the nearest neighbors based on distance of the values within our data set to the player of interest. And the number of neighbors that we're interested in is the K part. So we're going to set K to be the number of people that we're interested in that are similar to our player that we're looking at. And there's a lot of different distance metrics that you can use. There's different reasons why you would use some of, one over another. Here, we're just going to use Euclidean distance, which is the same that we used in k-means clustering when we did that I think that was the X-Men episode. It's the most common. It's just going to find the straight line between points within our data set. Now, to use this algorithm, we're going to need the data in a wide format. And generally what you have is one row per person with a number of different features that you're trying to identify the closest, most similar people to that individual. When you do this, you often have various features that you're looking at. So because of that, just like we did with the k-means data, you would normally go through and you would scale, like z-score or min-max scale the data in some way so that all the features are on the same scale. That way, features that are really, really large don't drown out features that are really, really small, right? Like if you're clustering families, maybe household income is going to be a very large value, but number of children or pets is going to be very small. One would drown out the other. So you're going to scale those. In our case, we're actually going to be building our KNN on the time series of a player's Vorp over his careers. And so because of that, I'm not going to scale any of the data. The data is already scaled. Every single year is scaled on this, they're all on the same scale. They're all on that same Vorp scale. So we're just going to simply take our data from that long format that Ellis just pulled in. We're going to spin it out into a wide format, pivot wider, based on taking the names from the experience column, which is going to be the numeric years of experience for that individual, and then the Vorp value, so their value over replacement for that given year, and that gives us a cool column of features. And you'll notice all the NAs. That's a feature of pivot wider. So basically, it knows that, okay, the longest player that it's seen has played 18 years. So anybody who's not played that long is just going to get an NA, and it always defaults to NA. You could change this. If you had reason to believe that those should be zeros, you could simply do that, or -9, or 9,999.
I've seen lots of cases in data sets where they're not gonna leave values that don't mean anything as NA. They could be like -9, -99, 9999. So this is be sure to check your data set and check your assumptions that if it's blank, or that if a value is there, that it actually means something. Because I've seen -9 way too many times.
And that's like a classic kind of move in data science, is like they just assign it. They assign an NA some like obtuse value that doesn't have real meaning. For us, we want to leave the NAs because if we were to say give these all zeros, we would be making the assumption that those players in all of those years are a 0 level value over replacement player, which we don't want to make. So we actually want to leave the NAs. So now we've got our data set prepped in that Vorp wide, and we're going to walk through the example. Before we dump this into the Shiny app, we're going to walk through the example of how this works. So we're going to take a player of interest. And in this case, the first player I saw when I opened the data set was OJ Mayo. So he is the player of interest.
Congrats, OJ.
Yeah.
Hopefully you're watching this and you're like, oh, wow, they really value it.
Yeah, right. So we're going to filter out OJ Mayo. And when we do that, remember, we have 18 rows or 18 columns for every single person. So OJ is going to have 8 columns of experience, and then he's going to have a whole bunch of NAs, right? He's going to have 10 extra columns of NAs. We want to make sure we dump those. And so we're just going to do that at the bottom there with select. We're going to say select where any column where the sum is not NA and it's greater than 0, right? So we're going to dump those NAs out.
Yep. Yeah, so this is a tidy select feature that exists. So they got rid of like the select if, the select when, or the select at. So now you can use this where field here, which is very similar to the mutate and across. It's a very similar concept here. Select where this thing is true.
Yep. So we've got OJ Mayo now. We've got his 8 seasons in the wide format that we like. We're going to get his max years because we want to basically identify the players who played longer than OJ Mayo. So he's played 8 seasons, and now we're going to create our training data set. So this is the data set that we're going to build our KNN off of. So we're going to take our wide data, Vorp wide, and we're going to filter out any of those players that played greater than or equal to the number of max years that OJ Mayo played. And then again, we're going to get rid of any of the extra NA stuff for those players.
Yeah. So probably, yeah, it's not going to be filtering that much. We actually probably could have gotten rid of this because we're keeping any players that are greater than.
Yeah, that's right.
2 years. So in theory, we have people out to 18. But it's still just a good logic check to have in there, just to make sure that you don't have any unintended columns that exist.
All right,
Cool.
So now we'll build our KNN. We are going to find KNearest Neighbors 4. So we want to find K equals 4 for no other reason other than 4 makes a beautiful facet. You could test this and try different reasons and try different things. You could set it to whatever you want. But we chose 4. That would be a lot. That would be probably every player in some way. So we use the KNN function here, and we pass it a few arguments. The first is the train set. So this is all the players that played greater length of time than OJ Mayo. And we're going to take only the columns that represent the time series of their Vorp over their careers. And so that's basically column 3 through the last column in that set, in the test set, sorry.
Yes.
So the test set is OJ Mayo, right? He only has 8 years. We want to find the players that were most similar to OJ through their first 8 years, and then we're going to project out the rest of the years. So we're going to take everybody from column 3, because columns 1 and 2 are the player name and their max years. We don't need those. We're going to take columns 3 to, in this case, 8 for OJ Mayo. We're going to take OJ Mayo's data set, and we're going to say, compare, using the Euclidean distance metric, compare the columns 3 through 8 from the train set to column 3 through 8 from the test set. And then the CL function, that's the true classification group that we're trying to look at. So here, it's going to be the train players. Those are the players that we want to be able to extract and look at in the next step. So we're gonna pass that as our class of interest. We want 4, and then we set the algorithm to the KD tree algorithm. There's a few different algorithm options there. KD tree is a handy one because it can work pretty fast for large data sets. So that's generally why I use it, but there's a number of options, and there's reasons why you would want to switch in certain situations. The result from the KNN output is what I would say not super handy. At times,
it's not easy to read.
Yeah, it's sort of like this weird list, but it has 2 key attributes that we're going to want to look at. The first is NN index. And so those are the row indexes of the 4 most similar players in the training data set. And then the next one is an index of distance. And we don't use the distance here. I'll explain when we make our forecast on the future years how we might use those indexes. But those are the 2 key pieces of this similarity matrix. So what we'll do in the next section here is we're going to take those row indexes and we're going to extract those players. So we're going to create a new data frame by binding the rows of our test data. So remember, that's OJ Mayo. And we're going to bind that to the training data where we're taking the attribute NN index out of our KNN similarity list. And so now we have a data set of the 4 most similar players in OJ Mayo. So there we have a table of 5 players with 20 columns, the first two being the player name and their max years, and then the other ones being years 1 through 18. Okay. Now we're going to make our forecast. So we take our new data frame, we ungroup it, otherwise you'll get a bunch of nonsense because it stays grouped. And we're going to spin this back to long. So we're going to pivot longer based on the columns where any column has a value that's a digit.
So, and because this is also a tidy select feature as well, and because we created our data set, we know the only columns that have numeric values in them. So this is a regular expression. This is find any digit, right?
Yep.
So we know that the only columns that contain digits are the years, or the years experience that we have here. So that's why we're going to be taking it from this wide into the long format. We're able to use matches D.
Yep. And we take the the names from the experience column. So again, that's the years. And we spin that out into the values being the Vorp. And that gives us our cool data set. You will notice that experience is a character value because it's coming from a column name. So in the next step there, we're going to turn this back into a numeric as it should be. We're going to filter out OJ Mayo because remember, we want to make a forecast and we don't want OJ to be in that forecast. And OJ doesn't have any years past 8 anyway, right? You can see he has NAs in years 9 and 10 at the bottom there. So we're going to filter him out. And then we're going to group by experience. Oh, we're going to filter out OJ Mayo, and we're going to filter out all of the years that are greater than OJ Mayo's last year as well. And that's a really important piece too, because we want to make this projection on years 9 through N.
Yeah, however many max years, the most similar player that has more years than OJ. It's confusing.
Yeah, that's right. That's right.
It's a background. It's a flippy situation there.
So now we're going to group by the experience of those years 9 through whatever, and we're going to take the mean Vorp of our 4 most similar players. Now, this is a very simple and very naive way of doing this. One other way we could have done this was to actually bring in the Euclidean distance, right? The similarity score. The distance score from our KNN similarity data frame, and we could have weighted the Vorps of these players. So the guys that are most similar, the guy that is most similar would carry more weight in the forecast than the guy who is least similar. But we kept it simple. We just went with first iteration was just a basic mean, and then we're going to filter out any of the NAs to get those out of there so that it looks nice and clean when we're done.
Cool. So now we end up with a data frame like this that has years experience that we're forecasting out from, and the Vorp that they actually end up having.
Yep.
Or that we are forecasting this player have.
Yeah. So that's OJ Mayo's forecasted Vorps.
Yep. And so now what we're going to do is we're going to tack on our forecasted Vorp into OJ's original data set there so we can do some nice plots. So what we're going to do is we're going to take this new DF data set here and keep OJ Mayo. We're going to spin it down to be long again. No, we don't do that. Sorry, ignore me there. This is actually what we're going to be doing. I had some extra code in there. We were experimenting with some stuff. We're going to take the test data set, which is OJ Mayo's data set here. We're going to pivot longer. That piece is still correct. where we're now going to take it from a wide to a tall data set here. We're using the tidy select feature this time to select columns 3 to the last column that exists here. That's also another tidy select tool as well that I recently discovered. And now we're going to use bind rows to add the forecasted Vorp that we have to it. So this is going to calculate, or it's going to create this data set here and bind in a data frame that has 2 columns, player and the forecasted Vorp that we have. So we're going to add this into that original data set. So now we end up with a data set like this, where we have these extra predicted years and the Vorp for that. And what we're going to do is we're going to then mutate this data set to populate with experience so that we have those values in there. We're going to repopulate it with the maximum number of years. So we're going to be replacing those NAs with the max years that the OJ had. And then we're going to fill in this value here, which is our predicted years. So what are we predicting? Or this is a flag, excuse me. This is the flag identifying, is this a predicted value or is this the actual value of the player? So that we can drop that in there. So let's run that. So now we end up with a data frame that has all years 1 through 14 with all their values in there. However, we're going to be plotting this, and we know that when we're going to be using lines to plot, and there needs to be, and we're going to be grouping by prediction state and setting line type to be that. And so it's not going to draw a line between groups because it doesn't know that they're related. So I'm going to have to duplicate the last value that we got for OJ in his last year and set it to be, oh no, actually that's a quote predicted value. And this is just for plotting purposes. And then, so this is what this bind rows is doing. I'm using dot notation, so I don't particularly like doing it this way, but I'm going to grab the, from this data set here, we're going to grab the case where experience is equal to max years. So this would be when this max years is equals to experience, which is this value here, which is the last time that we don't predict the Vorp. Change it so that key it as we predicted that. And then rearrange the data set so that it maintains the integrity of, here's the first values that are actually his, this is the value that we inserted, and then here's the values that we're predicting. So now we're going to plot this. First thing, of course, we're still going to have to mutate our data set as we figured out as we were generating the data set, or the plot. We're going to have to convert the predicted years into a factor so that we can more easily use it to define things later on. We're going to set it actually to be a column name called projection, and it's 0 or 1, yes, no. We're going to send it into a ggplot. We're generally defining the aesthetics to be the x-axis is years experience, y is the Vorp that we have. We're setting the group to be, is it a predicted year, and the color to be the predicted years as a factor. We're going to draw in some vertical and horizontal lines here. This H line is y-intercept equals 0, so this is just a straight line across at 0, and this is just to make the 0 a little bit more bold. We're going to add a geom V line, so this is a vertical line this time, and we're going to draw it at the maximum number of years OJ played. So this is the point at which it inflects from the values we actually have to the values we're predicting, and it's going to be a darker gray color as well. Now we're actually going to draw in the lines that are going to be connecting the various years, so you can kind of easily see the trend lines. It's going to be inheriting these aesthetics that we have up here, but we're going to also now have a line type is equal to projection. So this is going to be the 0, 1 situation. Did we predict it or did we not? And the size is going to be 2, so it's going to be a little bit thicker than the standard line there. We're going to draw points as well, just so that we can see the little dots at each year as well. It's going to have the lines over it. We're going to scale line type manual. So this is where we're defining how the line type should look. We want the actual values to be solid, so that's how we list it first. so that it's going to match up with the first predicted value, which is going to be 0, and then values dashed. So with the predicted years, we're not so sure about those, so we're going to set those to be dashed. Just visually, dashed lines are kind of less solid. We're not as sure about them. We're going to scale the colors as well. The years we already know the values for, we're going to set them as black because they're set in stone. I mean, just color theory and whatnot. Gray is a little bit more wishy-washy. We're not as sure about it. So this is also the projected values as well. We're setting the Y limits because we want, even though this case we're only doing OJ, we could use this for multiple players, and we want to make sure that the Y scales stay the same, so it looks visually the same across every plot that we generate. We're going to add labels for what the career value over replacement is, the title. Y-axis, we're not drawing, we're not going to be putting Vorp or anything in there. We're going to have no label for that, and X is going to be the years in the NBA that we calculated since we see them. So from 2000. I don't want there to be a legend. That's just an aesthetic thing that I want. So legend.position equals none. And then I'm going to set the text title to be a little bit larger than we defined it earlier, because when I created it, I felt like the title needed to be a little bit larger. And the face is going to be bold, so it's going to be thicker. So let's create this. There we go. So this is OJ's career and where we're projecting it to go. Doesn't look like it goes up any.
Not going. Yeah.
Sorry, OJ.
Well.
Sorry.
Well.
So yeah, it looks like in the early years looking like there's some value over an average NBA player. Kind of dips down a little bit, and we're not really projecting it to get any better. Sorry, bud. So that is the concept and some of the plots that we generated that we're now going to be turning around and applying into our Shiny app that we've been discussing. Now we're going to jump into how we'd apply everything we just learned into a Shiny app. And we're going to kind of skip over some of the details because we covered it in depth here, so we can focus on the Shiny concepts.
And this is actually like how I tend to work with these things, because Shiny, we're going to drop this in as a tab set, as a new tab, like we did last week. Usually I'll build my models or get my concepts down in a new script, and then when I have it where I want it, I literally just go into my fluid page user interface and I say tab set, and I drop in what I want the person to be able to select, and then I go down to the server and I add in all of the steps, replacing OJ Mayo with input $player, and kind of let Shiny do the rest.
Exactly.
Is what we're going to do now.
Exactly. So this is growing on what we did last week and what we did the week before that. So new packages that we have in here is a library FNN, which is what gives us the KNN function. Everything else is the same here. We're now going to actually have our Vorp TS, Vorp time series, which is read off of season stats and spun out to we didn't spin it out. This is the same data set that we had before that we were just discussing. Some data prep that we have for the prior week's explanations, the functions that we used in prior weeks with the helper functions here. And now we're going to jump into the UI, where the only change that we had to do to the UI in order to add in this new feature is, because we're using tab sets, we're going to add to our tab set panel a new tab panel. What? Where we have a tab panel here. We're going to call that tab Vorp Career Twins. So it's like which players are similar. It's going to be full width. We're going to have an action button, because KNN could potentially, or some other algorithm that we want to use if we want to drop in a new algorithm, could take some time. We don't want it to automatically run every time we select a new player. So we add in this action button here. And so what this will do, and we'll explain in the server in a second, is until you click the action button, it won't calculate what players are similar and what the forecast is. And this is just to protect you if you're like clicking through a lot and looking at different players in the different tabs. You don't want this to be trying to run in the background. It's just going to slow down your Shiny app experience. So this is going to do that. And then we've got two plots that we're going to be outputting. The Vorp prediction, which is the player, like the plot that we literally just looked at. where it was the player up to n years that they played, and then the projection after that. And then we've got a new plot here underneath that, which will be Vorp twins, which is the 4 players that we determined were the most similar based on the time series. We're going to be plotting those, and you'll see a new thing here that we have set, which is height. So this is defining how tall the plots are going to be in the Shiny app. We haven't done that in the past. We let it use the default value, which I believe is 400 pixels. So we're going to keep the Vorp prediction at 400 pixels. We're defining that. But Vorp twins, because we've got more data just in it, like we're going to have 4 facets, we're going to set the height to be a little bit taller, just so that it's not so dense and squeezed down when you're viewing it. All right, so that is our UI piece. That is the only new piece to our UI. Isn't that nice that we can just we built up the tab set panel and we can just pop that in there.
Chunk it in.
And it's just super simple. All right, so now let's scroll down into the new tab 3. So all this content here we covered in the last couple of weeks. Definitely go check it out if you haven't yet. I think it's really fun and it's really foundational to what we're going to be talking about now, which is how we're going to be doing our Vorp nearest neighbor comparison. And this is tab 3. So this is also how we're kind of organizing our Shiny server as well, where we have each tab kind of in its own little self-contained little section there. So this piece here, calculating player Vorp, this is essentially the train data set that we were using. Is it train? Test, excuse me, test. It's a test data set.
This is a player of interest.
Yes, so this is for the player of interest. So we're going to take the Vorp TS data set, which is a long data set here. We're going to filter to keep the input player that the user selected, and pivot wider again so that it's going to take it from this long data set into the wide data set and set it to be player Vorp. And this is going to be reactive, so think of it kind of like a function that accesses that information there. But now we're going to so we're going to skip this for a second. What we're going to do is, so we added in that action button, right, to protect us from accidentally, when we change the input player, it's not going to automatically rerun everything, because that could potentially take some time. Thankfully, this KNN algorithm is fairly quick, but if you have a lot of people trying to run it, trying to access this, you don't want it just to automatically update every time. So we put this action button in the very beginning, which will tell Shiny, hey, when you click on this, run it. And this is how we're telling it to do that. So the ID for that action button that we had was player Vorp KNN calculate. And so now anytime that action button gets clicked, it's going to see, so we're going to use observe event, and it's saying, oh, this input got clicked. I should execute the code that's within me. So this is what the observe event does, and it's now going to start calculating KNN and forecast and all the stuff that we just discussed. But as we know with the observe event, it doesn't directly output values, right? We need to capture that so that we can use it later on to produce our plots. And this is where reactive values come in. So reactive values are essentially like this kind of meta reactive situation where we define our reactive values right before the observe event, and we can then insert into our reactive values the new values we want it to have. And then anytime it's going to then update, they're essentially reactives now as well. So we can then access those later on in other pieces of our Shiny app, but we're capturing results from our in observe event. At least that's how I think about it. I'm sure Joe and Winston and all the Shiny developers probably have a much more refined understanding of this, but this is how I like to see it. So we have KNN Vorp, which is our reactive values container. And we've got 3 different values in there. We've got KNN DF, we've got forecast, which is our forecasted data set, and then we have players, because we want to record who did we calculate this for. Should we change our input player? We want to make sure that we've captured that information there. So now we're going to hop into our observe event, and this is the same exact code that we just explained, where we've got our test data set. We're going to calculate our training data set, which is going to keep all players that have at least 2 years more experience than the player of interest. We're going to calculate the KNN similarity using KNN. We're going to take out the 4 nearest players in the test data set, this time we're applying it to KNN similar DF. And here's how we're going to be accessing it output. So we're taking the KNN Vorp, which is our reactive values container, and now we're going to be assigning it into KNN DF, which is the part within the reactive value that we're assigning it to. And now any point later on, if we refer to KNN Vorp $KNN DF, it's going to have that value in there, which is pretty nice. And now anytime that updates, anything that's referencing that will also update. Now we go through and do our forecast. Same exact situation where we take all the players that aren't the input player, calculate the average Vorp for that, and set that, and that's our forecast, and produce the bunched together data set where it's the player's predicted Vorp combined with the actual Vorp that we have. And this is called player calc Vorp, where we're now assigning that into our reactive value as $forecast. And we also wanted to make sure to capture, like I said before, who did we calculate this for? Because this is really important, because we don't want to accidentally change the input player and then it still be showing, oh, well, this player is going to have this Vorp when it was actually calculated for a different player. So we want to make sure to be capturing that as well, and we're assigning that into KNN Vorp $player. All right, so now we've got our reactive values that have all the pieces of information that we need to generate our plots. So this is, now we're going to go into our render plot, and this will be the first plot that we're going to be creating, which is our Vorp prediction. So Patrick, do you maybe want to take us through this piece here?
Yeah, so this is going to be the player of interest plot that is always going to show up until you hit the little button, hit our radio button. So we're going to use a little if statement here to say if the input player equals the KNN Vorp players, then we're going to go ahead and we're going to plot the forecast data, right? So we're going to render that plot. Or else, if it doesn't equal the KNN player, then we do plot data Vorp TS. So we're going to filter out the player of interest and mutate predicted year. Oh, only showing their predicted, non-predicted years, right?
So this is taking from the Vorp TS data set and only keeping the player of interest up to the number of years they played.
Up to whatever they had, yeah, exactly. Predicted years equals 0.
And now we're going to go through and generate the same plot that we had before, where we have the plot data, we generate the projection data or field there. So this is the same one that we just went through in the last one.
Same stuff.
Same sort of stuff here. So we're going to kind of scroll over that. So it's career value over replacement for the player. It's either going to be solid black line if it's the actual values, and then dashed gray line for the projected values. When we don't have the projected values, it's just showing up to the years they played. Now we have another plot that we're going to be generating, and this is the Vorp twins. So what 4 players are the most similar, because we might want to view how they did as well. So we want more than just the projection. We want to look at the player themselves. And so what we're going to do here is we're going to wrap it inside this, again, input $player equals KNN Vorp player. So this is double checking to make sure that the players, we're not going to be showing you, here's the 4 similar players when we've now changed our input player, because that is no longer correct. We don't want to be doing that. And so now we're going to hop in, and so it won't produce a plot if the input player has changed from the player you've calculated it for. It's just going to show up as blank, which is kind of nice. So you don't have to remember to update that. Patrick, do you maybe want to take us through what's going on here?
Yeah, the plotting stuff will be the same. I think the main change up at the top here is that we're filtering out the player of interest, right? Because this is going to be effectively from the last script, this would be our test data set, our test players, our 4 players of interest. And the mutate here, this is just going to give us a little nice thing. Even though we didn't use the weights to weight the forecast, Ellis did go through actually and did this part here, which is kind of nice, was he pasted the number of the player's index. So basically that gives you the a look at like which player is number 1 closest, number 2 closest, number 3 closest, number 4 closest, etc. So that's what the paste is doing here. It's basically taking the player level and it's pasting the value of that player level 1, 2, 3, or 4 to the player name with that little hyphen between them. So you'll see it in the plot here when it comes up. And then he does in the next line, he turns it into a factor. So the factor helps us preserve the order, right? A factor is like a character variable with some explicit ordering to it. So he just changes it to a factor to ensure that the players come out in the facet as 1, 2, 3, and 4 in a logical way. Then, just like in the previous scripts, we're going to go ahead and spin that out into the long data frame again. Mutate experience as numeric because, again, it comes out as a character variable since it was a column name. And now, again, these are going to be all of the same types of things that we've seen before in terms of the GG plot, experience on the x-axis, Vorp on the y. We're setting colors. We've got our H line and our V line to give some context to the time series that you're looking at. We've got the line and the point to represent our time series for that player. We set the facets to be the individual players. We only want 2 columns so that it just looks nice and kind of blocked, 1, 2, 3, and 4. We set the scales to be free X because some players will have played longer than others within this comparative set. Color manual, again, black is going to represent the true years. Gray is going to represent the projected years. Y limbs are the same. The labels, we changed the title here to say this is most similar players, career value over replacement. And then a little bit of theme stuff to make it kind of prettied up. And that should be the entire server.
Yes, indeed. That is. So, all right, so now we're going to run the app. I'm going to zoom out a little bit because I think when we're zoomed in, it kind of tends to look a little funkadunk. And here we go. All right.
So tab 1 is what we had from week 1, from Shiny Data 1, which is going to be our kind of baseline stats for scoring and defense. Week 2, we added a tab that said, hey, we want to see Vorp over time, but we want to be able to compare the players, right? So we want to be able to select a few players and see how they've done. And then tab 3 says we want to see Vorp over time, but instead of comparing players, we actually want to identify players that are most similar. So you'll notice before we hit the button that all we see is LeBron up to the final year. In this case, it was 2017, the final year that we have observed in the data set. Now we'll make a forecast, and so now we see LeBron forecasted out for several more years. And the players that are 4 most similar players we have are Garnett, Tim Duncan, Gary Payton, who appears to have dropped off a cliff after year 12, or I think
14.
What was that, 14, after year 14, and then Jason Kidd. And the line, you can notice the vertical line for these 4 similar players gives some context because what that vertical line is it's the line of LeBron's final observed year. So basically you're looking at where was this player when LeBron where were these players relative to where LeBron is now. And also everything to the left of that line is what the KNN was built on. So for those 4 players, everything to the left of that line represents what we called the test data set. And for LeBron, everything that's in black is the train data set. And everything that is in gray for LeBron is then forecasted off of the players' data, the 4 players' data of everything to the right of their line. And so we can select different
I don't know. I like picking stuff. I don't know why.
Yeah, he's really good. So you'll notice there, no projections, nothing is there yet. We only see up to the year that is final observed. And we'll go ahead and we'll click it, and we get out a bunch of projected time period for him, and we see he's got Tracy McGrady, Kobe. Anytime you're in a group with Kobe.
It's pretty good.
Ray Allen. Gary Payton makes it again.
Hey, you know.
Nope, nobody wants to be Gary Payton in year 15.
You don't want to plummet there,
No,
but
no,
I don't know.
no.
It's interesting to see how you can kind of combine
Ray
all.
Allen, I mean, he stayed better than replacement for like, I feel like he's still playing. He'll never stop playing.
Never. Just keep on playing as long as he stays above the average. Still playing.
Why not? Why not?
Yeah. So this is a look at our version of the Carmelo projection and most similar players. You might notice that we took a slightly different approach than 430 or 538 did, where we're looking at the entire career. It looks like what they did is they looked at the last 3 years and any last 3-year chunk of any other player. And so that could be another way that you look at your data set is you'd have to do a lot more data manipulation up front than we did, where you're going to create a new row for every 3-year period, and it's going to have to be a moving window. So the data set is going to blow up like a lot. Every n-3 for each player.
Yeah.
That's the number of rows it's gonna grow a lot, but that'll be more similar to what Carmelo did and the way Carmelo app works and whatnot.
Yeah.
But this was another way that we thought was similar enough to show the concept without having to create a massive data set.
There we go. Cool.
Well, we always appreciate some feedback and what y'all would like to hear more about. Do you want us to go into this more? Do you want to have it go, hey guys, we didn't really care about this. Tell us about something else. We had a great time putting this together. It was a lot of fun to spend a few weeks on the same data set and really explore it and try to explain how we'd approach it. So love feedback on that. I guess we'll just call it here. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward. You can find me on Twitter at OSPPatrick. You can find both of us on Twitter at Tidy_explained. Hit us up there, or feel free to email us if you don't want to speak in public. That's tidy.explained@gmail.com.
All right. Thank you, and keep on exploring your world.